So as we grow in our population, we're not really looking ahead, that there's a finite amount of space for us to go. There's a finite amount of prime farmland that we can use to sustain ourselves and feed ourselves. So why don't we look at site areas that were maybe previously developed? Anything on them. Parking lot, anything. Because that's not something we're going to farm on later. It's about being smart right from the start, including selecting where you're picking your site. Site design and management. So how are you affecting the wildlife and the existing ecosystems? Can you reduce that impact? Let's say you are in a green field that's never been touched before. Well, then maybe you're a little bit more sensitive during construction and in your site design. So maybe less hardscapes everywhere. You're keeping things more in their natural state. This is an important thing for a contractor to coordinate too, because if you have a design to keep this beautiful field or wetland or whatever it is in its natural state, but the contractor is, putting their trailer on it or, has big equipment on it, then you have a problem. You've lost that natural state of it and all that beautiful biodiversity and things that you can't recreate by turf grass or something we would artificially do. So it's, once again, integrated project delivery, a contractor understanding the goals, an architect understanding the goals, the owner signing on and saying, okay, we've got this site. How are we going to work within the best way possible to make the smallest impact we can to the natural ecosystems that are there and thriving? Because we do depend on those ecosystems. It's not just being nice to them, it's being nice to us. Transportation, big one. We saw when there was a re-weighting of the lead rating system that CO2 emissions became a priority from that scientific process they went through with the EPA and with NIST and Tracy using all these tools. This was seen to be very important, indoor air quality and energy efficiency. So these relate to CO2 emissions, which is related to cars. So once again, site selection. Are you somewhere where there's different choices for how you're going to go around? Alternative transportation, mass transit. Portland does it very well. We have a streetcar. It's coming close to my office. I'm very excited about that. That's going to open up a lot of opportunities when I can't bike around, which is another thing that's great about Portland. But just having a means other than the single car usage, even if you're encouraging carpools, van pools, subsidizing bus passes, there's a lot of ways to encourage this. But it's not just our buildings, it's how far do people have to get to our buildings? Or if they live in our buildings, how far do they have to go to get their basic amenities done, like banking and grocery shopping? That's what the Pearl does so well with that new urbanism we talked about when we talked about lead neighborhood development. Stormwater management. Don't add to erosion and sedimentation. There's a lot of consequences to all of this impervious surface. So impervious surface is all the asphalt and sidewalks that we have that don't let any rainwater infiltrate back into the ground like it naturally would. So it's all running. It's all stormwater runoff going into our gutters, going into that combined sewer. Now you saw the houseboat I grew up in. Now you see why I take it personal when that combined sewer overflows from too much rain and too much runoff and goes in the rivers. So we have all of the contaminants from the roads, from cars leaking, all the fertilizers from farming coming in. We know what those fertilizers can do, and we saw what DDT did to birds when the population diminished quite a bit. And the shells of their eggs weren't able to survive because they were too thin from just being basically poisoned. Well, it's not good for us either, go figure. So it's really important. The stormwater management is huge, and it's a really big priority in Portland, which is great. So encouraging on-site infiltration. We'll look at a lot of strategies on how to do that. So now we are in the first section of LEED. So we're putting in the context of LEED 2009. We saw those 5 main categories: sustainable sites, water efficiency, energy and atmosphere, materials and resources, and indoor environmental quality. So we're talking about sustainable sites. We're not going to be able to cover every credit. We're going to look at some really heavily weighted ones. You kind of start seeing it in the context of the LEED rating system. But unfortunately, we can't cover all of them. Erosion. Soil being moved by stormwater runoff or wind. This is a huge one. So stormwater runoff described how that's a big deal in Portland, Oregon, but also wind. We had a little something called the dirty 30s, where people basically had homes in our beautiful lush prairie that were covered in dirt, couldn't grow anything on them, because after the Industrial Revolution, we had basically just plowed and plowed. We thought we just had the best solution ever made, and it was great. We were efficient. We could cover a lot of land quickly, a little too quickly. We weren't respecting what was already there. Native plants function the way they do for a reason. The prairie grass is very deep-rooted, has huge anchors that are holding itself in, because there's no trees or anything to buffer the wind. So when we decided to basically plant what we want, overcropped, those plants weren't able to survive with all the wind. And they left, topsoil left, we were over-tilling, and then all of a sudden we can grow anything. And we created a Dust Bowl. So it's not just nature changing on us, we're triggering a lot of these things. I hope we realize our mistakes sooner this time. That's really what we're facing right now, is do we really need to see all these catastrophes to change what we do and respect the natural systems and work with them a little bit more, learn from them. That's what this is about, being sensible. Sedimentation, addition of soil to storm sewers and streams. Turbidity, reduces sunlight that triggers photosynthesis. That's how aquatic vegetation survives. So if you have all of this soil from sedimentation in the water and smaller particles that don't sink via gravity, then all of a sudden you've got cloudy water and not a lot can live in there. Eutrophication, so that's an increase in chemical nutrients found in fertilizers. And then all of a sudden you have these algae blooms. I have seen them, and it's not a pretty picture. So kids, we talked about that a lot of our most decrepit buildings in this country are schools, and that we're trying to change that, but we let it get a little too far. So it's really the fact that kids are really susceptible during these developmental stages to toxins, and a lot of asthma and problems like that are coming from the VOCs, the volatile organic compounds and things in those spaces. HVAC systems that don't run efficiently, that aren't kept up, the maintenance isn't held up. So it's really important to be addressing schools. So how LEED addressed it is there's actually a prerequisite that says if it was previously a landfill, it cannot be a school. And any other type of brownfield can be remediated and get up to standards that can have a school on it, but it's really about being sensitive to the sites you choose. And like we have a little girl here rolling around, who knows what they put in their mouth, being sensitive to the actual site itself as well. So you want to look at EPA standards, ASTM standards. Those are our testing standards to really see if we're meeting those codes. So some strategies. Of course, a little shot of Europe actually working with its environment there. Just kind of looks like it naturally evolved like a mountain out of those rocks. Not something we see much here today. So protect sensitive areas. So limit that building footprint. And that's what I talked about, even contractors. Limit your construction footprint as well, taking that a step further with integrated project delivery. So thinking about how you want to design the footprint of your building to maybe work around what's naturally there. That can be a cost saver too. Maybe don't dig out that boulder. Maybe work around it. Maybe don't dig up all those trees. Make it a part of your shading that you want to use for your building. Help with passive cooling and daylighting by using natural vegetation around you. There's a lot of cost benefits from looking at this environmentally sensitive as well. Triple bottom line. So integrating natural surroundings, like those buildings are emerging from those rocks, and for schools, help kids see how they're engaging with their environment and how buildings impact that. So there's a push for integrating that into the curriculum and to actually having kids engage with the buildings themselves, whether it's a composting program, a green roof, and kids are sponges. What we're teaching them is what they're going to carry on. So I think this is an important area to be hitting, and it looks like we're going that direction, or at least LEED is really encouraging that. So there's that social side as well. Sustainability and equity is really the key to success here. Here's an example of credit within the LEED rating system for building design and construction, new buildings, that got more heavily weighted. So here we're looking in the context of LEED. So SS, remember, is sustainable sites. Title of the credit, development density and community connectivity. So this is what you would see when you first open up the LEED reference manual and look at this credit within the sustainable sites category. 5 points available for new construction, 4 points for schools, and 5 points for core and shell. So as I mentioned before, this was a change in LEED 2009, that they integrated core and shell, new buildings, and schools all into one manual, since they are closely tied. And it was confusing the industry. I ran into it with engineers not knowing which rating system we were actually using, because it wasn't well established. There wasn't a good pre-design phase. We were all talking about it and signing on together, so there was confusion. So right here in the same reference manual, you could see the credits, but maybe they get a little differently weighted in terms of points in those credits for those different rating systems, new construction, schools, and core and shell. So you'll see this pop up on top every once in a while to give you an idea of how that varies. But the intent of the credit, most important thing about the credit is the intent. There's requirements for each one that, LEED AP Plus, which is not what we're talking about today, that really in-depth knowledge of the requirements and the percentages and thresholds you have to hit, that comes after just understanding the intent and what you're trying to achieve. So in this development density and community connectivity, we're just talking about channeling development to urban areas that are already developed, so we're connecting to that existing infrastructure and we don't have to do everything from scratch. So we're not bringing all the utilities, all the roads out to some far off location, using what's already there. Once again, cost saver and just helps with our resources and demand as well. So you're protecting untouched greenfield. So once again, terminology, greenfield means it has not been touched by any sort of development, hasn't been graded, hasn't had a parking lot on it, hasn't had a building on it, so any type of development. So you want to preserve that natural habitat and those natural resources. So we're not saying, suburbia is terrible, but traditionally maybe wasn't looked at in the right way. Maybe it can be reassessed. We have a good example in Oregon, in Hillsboro. Orinco Station is in Hillsboro, where there's a lot of suburbs, but they looked at it a different way. They kind of took our Pearl approach and had mixed-use developments, housing on top of cafes, on top of stores, banks, all with kind of like a half-mile walking radius, no big freeways in between those basic amenities. So you don't have to use your car as much. And our max line goes out there. So another great thing about Oregon, thinking about reducing automobile use, reducing CO2. Develop on previously developed land. So we're seeing synergies here. Building reuse, if there's a building on there, so you already have resources, why just toss those aside? Assess what's already there. Maybe you weren't thinking about using brick in your building, but maybe it could become a planter or a pathway or something else. Thinking outside the box and problem solving a little bit. So it's just getting out of that comfort zone a little bit. But to me, it's a lot more of a fun process. Reduce construction waste. So less is going to a landfill site if you're reusing it. Existing infrastructure, once again, not having to take those roads and power lines and utilities out to some natural place far away from the city or a developed area. Many sustainable site credits, actually part of the credit requirement is actually using a previously developed site. So just something to take into consideration if you're working on a LEED project. So develop in dense areas. So there's a lot of things that come with a dense area, previously established. And we're talking dense, it doesn't have to be those big skyscrapers. We're kind of talking about Europe. People love to go visit Europe because it's human scale. It's about average 2-story buildings. It's not overwhelming. It's walkable. That's really what we're talking about. And sure, maybe a city as well. So reducing urban sprawl, protecting that undeveloped land, protecting those resources, giving more access to public transportation, reusing service lines, roads, and community connectivity. So that's how LEED refers to it. You want to build in a densely developed area, and that's about 60,000 square feet per acre is kind of metric that's established by LEED. Once again, that's one of the benefits of LEED. It just gives us a metric. Well, what is a good density to be going for if we're planning a city or neighborhood design? So it gives us some metrics to lean on. And community connectivity, according to LEED, that's about a half-mile walking radius to 10 basic services. Restaurants can count twice. Once again, banks, grocery stores, laundry, those basic things that we're doing pretty much on a weekly basis on average. So you're reducing that automobile use. So this is within the context of that credit that we introduce. Development density is one option for satisfying that LEED credit. So development density is a measure of the average square footage of all the buildings within a density radius. So this is a credit that has a little bit of math. It's not too scary. There's a square root in part of it, but there is a purpose for that. You're just going to convert the acres of your site to square feet by multiplying it by 43,560, thank you, square feet per acre, and take the square root of that. Calculators can do it for us, multiply by 3. And that gives us this density radius here. So it tells us how far out we have to be considering the buildings to see if we hit that 60,000 square feet per acre number that says this is a dense kind of established area. So that's our density radius. Any building even touching that radius would be tabulated in a table that says we divided the building square foot by the site acres, and this is that building's density. You add those all up and you get an average. And if you're an average of 60,000 square feet per acre, then LEED's decided you're in a dense area. You meet the development density criteria. Community connectivity. There's different options in how you can achieve many of the LEED credits. And this one you could either do development density or you could do community connectivity. And that's a half-mile radius, as I mentioned. So you don't have to do any calculations, get the radius. Woohoo! So if you're already in an area that has laundry, library, bank, those type of services, and you can walk to it, it has to be able to have a pedestrian path, then you can meet this option pretty easily. Just listing those 10 different amenities, showing an aerial view where they're located. Radical ideas for the future. Vertical farms. Having the idea of actually incorporating some sort of vertical farming into this staircase here. So this is a conceptual design, and once again, it's thinking outside the box. So you have a stairwell. There's a lot of opportunities in these core areas that are just overlooked. These are areas we have to have. We're not going to think about them. Wonder if we tuck some vegetation underneath the stairwell where you have a void there. It's unused space. So that was the idea behind here, is actually having this glazing going up and around, and depending on the climate, how often those could be open, what they would be made of, how well insulated, would all have to adapt. The idea that sometimes it'd be open, it'd work like a greenhouse within the stairwell itself. Great idea. Vertical integration. This is Ken Yang's work. He is termed many different things, godfather of green, granddaddy of green, because he has been doing this since the beginning of his work over 40 years ago. And his work goes from eco-master planning, of really looking at the environmental systems and how we're interacting with it. He mentions that, with urban sprawl and taking these highways far out into natural areas, that it's not just where those developments are, the highway is disrupting the ecology of the whole trip there, because really it's depending on the whole space. You disconnect it, you've broken those systems, that ecology of the area. So he really brings natural spaces into the building. He wrote a book on eco skyscrapers that maybe you can interweave some of these green spaces up and into the building. So you can have an urban building that actually has big terraces, has natural ventilation actually working through, ramps, natural ways to get around. And like we discussed, people like to be in these spaces. We like daylight. Go figure, we like natural, fresh air. It keeps us more awake. It keeps us more productive. We're happier people. Brownfields. Once again, we're seeing an example of elite credit, this only being 1 point, so it's not as heavily weighted, but there are many reasons to maybe use a brownfield. And a brownfield means that it's contaminated in some way. And according to LEED, there's a couple different ways to verify that. Standards are important. As we're saying, there's a lot of greenwashing out there. There's a lot of chatter. So standards are important to actually verify things. So this would be either an ASTM standard verified that was ever found on some brownfield, like an old gas station. That's where I worked on a living building called the Delta House. That was on an old gas station, and there was some natural remediation that happened on site because nature does that. It actually has its own microorganisms and bacteria that fights things. But some areas we had to pump and treat and do some things too. But we did get some extra funding for that. So it's always that cost-benefit analysis. What opportunities do we have here? So you need an environmental site assessment to evaluate that, see what contaminants are on site, see what you're dealing with, or local, state, or federal government agency maybe said that this is a brownfield, this is contaminated to a certain level where it needs to be remediated, fixed to some degree. Or, according to LEED, it could just be a local cleanup program. Alternative fuel vehicles. So not just thinking about mass transportation, that's not available to everybody in every location. We're lucky here in Portland, Oregon. But alternative fuel vehicles are also very important. So we're talking about hydrogen, ethanol, hybrid vehicles, but maybe run by biomass, biofuels. But there needs to be some measure of how efficient these are, and that's what these are. So they have to be classified either as a zero emission vehicle, ZEV, or have a green score of at least 40 or more by ASEE, American Council of Energy Efficient Economy. And by the way, that was a refueling station for electric car outside of the Hawthorne Fred Meyers you saw an image of. So we're preparing for these changes. It takes the infrastructure. We have to lay down the framework for some of these big changes to be possible. So it's good to see it emerging. So sustainable sites, alternative transportation. This is an example where there's multiple credits associated with one concept. So sustainable sites, credits 4.1 through 4.4 are independent credits, but they all have to do with alternative transportation in different ways. There's a credit that has to deal with mass transportation, bicycle parking, having racks available for people to bike, but not just the racks. If you're going to work and you're all sweaty, that may not be appropriate for your profession. Maybe it's okay, maybe it's not. So have a shower facility within the building for people that are working there or using that space. If they live there, they're assumed to have their own showers, but if not, you're thinking about the showers in addition to having covered racks, a safe place for people to store their bikes. And the goal of it, once again, intent is very important, create a transit-oriented development, TOD, reduce pollution from auto use, and reduce land development from auto use. So not only are you reducing the CO2 emissions of the reduced amount of people individually driving to places, but also you're reducing the amount of parking area you need, the asphalt pavement that's impervious and has problems with heat island effect and stormwater we'll take a look at. So it's multiple effects. You also have to look at not just one element, but there's many sides to all of these strategies and things we're going to talk about. Vehicle miles traveled, a metric you can use, VMT. It's the measure of transportation demand that estimates miles associated with the project. So if you have a carpool program, you have parking spaces that are available for electric vehicles for a certain percent of your building, then you're reducing the vehicle miles traveled that are associated with your project. You're taking that initiative. Here's an example. Much more heavily weighted in 2009 is alternative transportation, public transportation. So it's basically encouraging take advantage of these amenities if they're in your area. So really in Portland, we don't have much of an excuse to choose a site that is pretty close when they sing. So 6 points for new construction, 4 points from schools, 6 points for core and shell. But here's what we're really talking about today. So 6 points. Do you guys remember how much it was to get certified in LEED 2009 rating system? 40? Yes. So 6 points is a lot for one credit, and this is just to locate your building within half a mile of a commuter rail or subway, or within a quarter of a mile of 2 bus lines. You could locate your site there. When you're going through your eco-shred and you have your scorecard out, you go, low-hanging fruit, this is easy for us. 6 points, we're within a half mile of the max line if you're in Portland. This is something you want to be able to identify early on in a project, to know your opportunities. When you're setting these targets for LEED certification or sustainability, you would want to know that this is something that's important in the new rating system. Because there are many incentives and other inclinations to get certain certifications, in addition to just the good responsibility and showing that you took these initiatives. So it's an example of within the same sustainable sites, credit 4 family, but it's 4.3, and here we're talking about low emitting and fuel efficient vehicles, like we looked at in that past slide, 3 points for new construction, so still pretty heavily weighted. That's why it's in orange. So that's providing preferred parking for low emission vehicles. It's the same for 5% of the total parking for one option. Option 2, provide a charging station to refuel those electric cars or whatever alternative vehicle it is for 3% of the total parking spaces. So once again, you have options in many of these credits and how you achieve it. So we're talking about 3% of the parking, or maybe it's 3% of the full-time equivalent occupant. This is another measurement that LEED uses for calculations. So that is really what's useful about LEED, is we are actually using a metric, something that is universal for understanding this LEED rating system or green building rating system that evaluates how sustainable a building is. So full-time equivalent occupant, you have to understand how many people are actually using the building. So you're not just counting people, because some people are going to be in there part-time. Whether maybe you work half-time, or you're in a retail space where there's transient occupants that are coming in and out. So how do you calculate it? So a full-time equivalent occupant would be somebody that's in a building 40 hours a week. Then their FTE value is 1. This is an important concept that runs through many credits within LEED rating system if you're doing calculations. Part-time or overtime occupant, you take the hours per week divided by 40. So if you're 20 hours per week, if you work half-time, your FTE value is what? 0.5. Thank you. So not scary math here, but just something you have to be able to evaluate. So occupant hours per week divided by 40. Site development. Once again, it has 2 credits related to it, but the intent is the most important part. Conserve existing natural areas, restore damaged areas, provide habitat space, and promote biodiversity. So biodiversity is that natural variation in the ecology and how these systems work that we really can't recreate. So when we cut down a bunch of trees and we replant one type, whatever we decide, we're not recreating what was already there. We have to be cognizant of what's native in that area and what actually is going to survive there. So wetlands can count towards open space in the LEED rating system, but now if it's a big crater or something we've created, it can have more of a slope of 1 to 4 on its sides. But here's a shot of Portland and how there's just kind of this wetland type area in the middle of a very vibrant community in the Pearl District. So this was just a choice that was made, I'm sure very early on, that we're going to preserve that land and let those natural ecosystems do their job, help us with stormwater management, lower our utility bills. Just let that site do what it's intended to do. Sensible. So you're mimicking natural hydrology. When we're talking about stormwater management, there are structural, man-made things we can do, and then there's more passive things where we can just try to mimic what the site would naturally want to do by itself, but because it can handle the rainwater that's coming down if we didn't have all this impervious surface on it that's causing all this runoff. So on-site infiltration, once again, this is where the LEED rating system is really aligning with code and it's based on your state and local jurisdiction. But in Oregon, on-site infiltration is a huge priority and something that's pushed heavily in our codes and keeps getting more stringent and more stringent. So it's easier to have a LEED building in Portland because we're already pushing for this energy efficiency in our 2010 energy code. We're pushing for it in our stormwater management codes for building. So it's already aligning naturally with the LEED rating system. So if it's on-site infiltration, it's just naturally infiltrating on site. You have to check your soil, your permeability. Somebody has to test that, see how quickly the soil in your area can absorb. Clay might be a little harder. You know, it varies even within Portland what areas can infiltrate at what rate. That'd be like a civil engineer might come out and do that or design these systems. But it's important for us to all be aware of why this is happening, why this is important. So naturally, pollutants are broken down by these microorganisms and by these chemical, biological, and physical processes that happen. So if you let it sit there for a long time, like a pond, a wet detention pond, then you give more time to this process to break down the chemicals. So by the time it gets absorbed, it goes back to the water table in our aquifers, it's treated. It doesn't have all these chemicals like if it just shoots off of our roads, brings those contaminants or fertilizers right into our rivers that some people are swimming in and trying to enjoy. So here's a little example of what happens when we develop an area. So this is natural ground cover. We're looking at about 25% deep infiltration. This is really important to the potable water that we need to consume, that fresh water we need. It needs to be recharged. That's part of our ecosystem we depend on. And only 10% of it's runoff. Some of it might flow away. And then there's 40% of evapotranspiration. So that's what vegetation naturally does. It releases some of that back into the atmosphere. Here we've got impervious surface like 75 to 100%, and not that atypical for a developed area. And here we only have 5% of it going back into deep infiltration, recharging those aquifers. That's a problem. If we look long term, when we get in the water section, we'll see why this is such a problem and why we are going to see some changes in the next few years. 55% of it's runoff, so we're just shooting it away. In Portland, we could be using this for many resources. California would be envious many months of the rainwater we could collect and be reusing. Our codes are just catching up with that now and letting us actually use that rainwater for multiple sources we'll look at in the water section. Strategies. So once again, I said there's structural things you can do, non-structural things you can do. These are really pretty cost-effective things to do. Rain gardens can be a nice aesthetic to a building. Vegetative or bioswales, vegetated swales or bioswales, kind of interchangeable. Underground parking. So if you have underground parking, you have less asphalt covering the site, so you have more opportunities for impervious surface, vegetation, and that's also a synergy with a few other credits, open space, keeping nice vegetation, and also heat island, which we'll look at. Open grid paving, so that's that photo right here, just showing that if it's 25% vegetated, then you can call it open paving according to LEED. And it can count towards vegetated space for some credits. I think I can walk on high heels and still get around here. Porous pavement or permeable asphalt, there's a few variations of this. So it's allowing, now this could look pretty similar to your typical asphalt. It's allowing for water to infiltrate through that asphalt. And below that, this is just a diagram of having this uniformly graded stone. So it needs to be 40% void space to allow that water to keep coming through. And then in this case, since it might be heavy traffic, maybe a lot of discharge from cars and things, you may want to filter fabric before we let it go back into that deep infiltration layer. More strategies. Once again, looking at a new model of building maybe. You know, they don't have to all be boxes. We can think differently. Green roofs would be a way to handle stormwater management, give more open space, once again reduce heat island, synergies in the impacts and the benefits we get. Here's an example of a green wall, but this is an envelope of a building, and the close-up is to show water is actually funneling down from the roof and going into this collection area, feeding this green wall and possibly being reused for other resources. And this green wall can have many benefits depending on your climate. Maybe you want that shading to cool your building down. Many benefits can come from this, helping the air quality and so on. Best management practices. So once again, this is for our stormwater management. So this is really about treating the quality of the stormwater runoff before it leaves your site. So you're reducing the total suspended solids. So we talked about turbidity, those little particles that are too small to go down to the bottom of the stream or river because they're just hovering. So in that case, you would need some sort of filtration. And here's one example of how to do that. Rain Harvest Systems manufactures this infiltration filter. So it goes right in this manhole, and then it goes through several layers of filtration before it actually goes back to the main line. Detention ponds are example. Cisterns are for large collection of rainwater harvesting for reuse. And as for LEED purposes, a separation of a combined storm and sewer is encouraged. All right, sustainable sites credits 7.1 and 7.2, heat island effect. These last three families of credits we're talking about are very important because what we're really talking about here is synergy. If you start looking at these strategies, they're all working together. So heat island effect is what happens from dark, non-reflective surfaces, collecting that heat, we've all felt it, and then radiating it back up. All right, so we're looking at strategies for reducing heat island effect. But remember, these credits that we're talking about right now, the stormwater management, the maximizing open space, the heat island effect, these all have a lot of synergies and things that work together. So when we look at this strategy, minimize the development footprint, all of a sudden you have more room for either vegetation. This case right here is grass paved system. So this is actually drivable back to this garage. So it can infiltrate the stormwater. You don't have the asphalt, so you have reduced heat island effect, and you have more green space. Ideally, if this wasn't a grass paved system and it wasn't a driveway, we'd want native vegetation. That's what infiltrates stormwater the best. It's very important because grass doesn't really do the job. But in this case, a grass paved system hopefully has also laid a permeable surface underneath it that's good infiltration. So for heat island, provide shade from trees and structures, or something that LEED 2009 started to incorporate is it counts PV panels as well. So shading on a roof from PV panels is seen to be reducing heat island effect. There's an interesting synergy between green roofs and PVs. PVs don't function as well, many of the systems, the more heated up they get. So if you have a green roof underneath it, that can actually be weighting down the panel itself, helping with wind uplift and the structure you need, and be helping with its efficiency because it's cooling the temperature, the ambient temperature of where the PV is at on the roof, because of that evapotranspiration we saw in that diagram with stormwater management. Using hardscape materials and roofing with high reflectance. So SRI. Do you guys remember what that stands for? Yes, well done. Solar Reflectance Index. So that's what we're looking for when we're choosing our roofing material. You want high Solar Reflectance Index. And that also applies to on-site materials, so that's concrete. That's any number of paving systems. You can calculate that SRI value and help make that decision. And it can inform other decisions, like putting slag into your concrete often makes it lighter. So it's actually usually cheaper, recycled content, and you're reducing heat island. A lot of synergies with it. or use open grid paving, 50% open, as we saw with vegetation in previous slide. So synergies with heat island. Green roof, review, stormwater, energy, open space, and heat island all get addressed by just implementing that one strategy. Recycle content. Look at slag in your concrete or fly ash. These both have recycled content in them and are good products you can incorporate into your concrete. So don't just look at SRI value. Think about what's actually going into these products themselves, depending on what type of system you're doing. Underground parking, synergy with open space, stormwater, and heat island. Light pollution. Minimize light trespass from the building and the site. So we saw when we looked at regional priority credits, this was important to Michigan. They made it one of their top 6 credits that are most important to a rural area in Michigan. So that's why they made that important for them, is to reduce sky glow. So you're increasing sky access, you're seeing stars. That's why we like to go camping or the mountains or somewhere, the beach, where we can actually enjoy that natural atmosphere. So you're improving nighttime visibility, glare reduction, safer for driving, reduce development impact on nocturnal environments. That's a big one, like in rural Michigan. And you want to look at this early on. So schematic design, you want to be looking about what type of exterior lighting fixtures you're choosing and how you're designing your site and integrating that into part of the process early on. If you have a lighting designer, that's fantastic, but if we're an educated team, we can all be working together on these ideas. Quotient Lighting has a lot of really interesting solutions. They were a part of the first Office of the Future, which is an interesting thing that's happening with the utilities down in Southern California. GlueMac's new headquarters got this new Office of the Future certification, and they were using quotient lighting because quotient's really looking at real solutions. They're looking at holistically. Like this fixture right here is mounted to a desk, and it's helping with task lighting. So you don't have to have as bright of ambient lighting. So you can reduce that energy consumption. Once again, we have cost savings there. And it's not, something, a big lamp that's sitting in the corner that you have to avoid when you're pushing papers around, because some people don't like that. That's why they don't like task lighting. So this is a nice little integrated system for task lighting with the luminaire right in there. And those are T5s, so they're more energy efficient. So the primary work zones have more flexibility and spaciousness.